A major reason why the Mule was successful in landing astronauts to the moon was because they employed a two-phase approach. Okay. There was a young engineer by the name of Tom Kelly. He was a Grumman scholar. He was a graduate of Princeton University. He was very instrumental in coming up with this two-phase approach to driving towards the moon. And the two-phase approach was, the first phase was to launch into an elliptical orbit around the Earth. And the second phase was to sling the payload towards the moon with an additional rocket burn. Next job. Next job. Nice going. Go to the second chart, if you would. Able to get to the first chart. All right, this is the entire vehicle. This is the Apollo vehicle. The first part of it is the Atlas V rocket. The Atlas V rocket was developed by Werner von Braun, who was a defector, one of the original rocket scientists from Germany, defected after the Second World War. Werner von Braun developed the Atlas V rocket in Huntsville, Alabama at the Redstone Arsenal. He later became the director of flight operations at the Cape. So he was actually, his group was responsible for the first part of the lunar mission, was to launch the vehicle into Earth orbit. So that was he was the director of flight operations. So the Atlas V rocket contained 3 stages, first, second, and third. And on top of that is what you would call the payload. The payload consisted of the lunar module, the service module, and the command module. A close-up of it would be the next chart. The next chart.
Next chart.
Okay, now enshrouded in the vehicle was the lunar module, and I'll mention that the lunar module, when you take a look at it, is a rather, sorry, thank you, is a rather ungainly type of vehicle. The reason being that the lunar module operated only in a zero-G environment, so it did not have and did not need aerodynamic features. Okay, so there is the lunar module, the service module, and the command module, which contained the 3 astronauts at the beginning of the meeting of the mission. The 3 astronauts were in the command module as it traveled to the moon, and also the 3 astronauts would re-enter the command module on return from the moon to the Earth. You can see here the launch escape system, which was developed in the event that an explosion occurred during launch, or if a veering off course occurred during any part of the beginning of the mission. The launch escape system would extract the command module away from the rest of the vehicle and allow it to parachute and splash down in the ocean, which is the normal recovery phase of the mission. Next chart. Next chart, and let me take a look at it here. Okay, this is kind of self-explanatory, but okay, this is the command module, and this is the service module. The command module and service module were developed by North American Rockwell in Downey, California. So they had the responsibility for those two parts of the Apollo vehicle. The only thing that I would mention on this chart is the fact that you can see the three astronauts sitting side by side, the service module, which also provides thrust and other functions in the mission. Next chart. Okay, this is the lunar module, and as I said, it's a rather ungainly looking kind of vehicle, but it did the job because, as I said, it operates solely in a zero-G environment, zero gravitational environment, and therefore there was no need, and was there ever any need for being aerodynamic. This part of the vehicle is called the descent stage, and this part of the vehicle is called the ascent stage. A few things that I could mention: the landing struts, 4 of them, the ladder leading down to the lunar surface, the ingress and egress hatch for the 2 astronauts to leave the vehicle and come back to the lunar module at the end of the mission. You'll see here 4 little rocket jets called reaction control engines, 4 here, maybe if you can see it, and 4 here and 4 at the other end, each of the 4 quarters. They are at right angles to one another, and they serve as stabilizing rockets to stabilize the vehicle, the lunar module, when the lunar module is not attached to the command module. So when it's in space, the reaction control engines act to stabilize the vehicle. What else can I tell you? The descent stage also has thermal protection because of the heat developed by the descent engine. When it comes down towards the lunar surface, the heat shield protects the descent stage. The descent stage, and maybe just go to the next chart. Okay, this is a nice cutout of the lunar module. The descent stage acts as a platform for the ascent stage. The descent stage remains on the lunar surface at the end of the mission, and it acts as a platform for the ascent engine. Now, the descent stage is made up primarily of the oxidizer, which I believe is called aerosine. That's the fuel, rather, aerosine, and the 2 fuel tanks and the 2 oxidizer tanks. They serve as part of the liquid propellant for the thrust of the engines, so that with the assistance of the tank, the helium tank, the helium, an inert pushes the fuel and oxidizer into the engine, causing the explosive reaction, which is the thrust of the engines. The descent stage also has a water tank and space for scientific equipment, I guess that's about it. And the ascent stage shows, if you can see it, space for the two astronauts. There is also a hatch over here. It's called a docking hatch. And this is where the command module and the lunar module dock so that two of the astronauts would enter the lunar module for the lunar mission. And I can show you the S-band antenna, the VHF antenna, the rendezvous antenna, which is used as rendezvous radar antenna, which is used for rendezvousing with the command module at the completion of the lunar mission. What else? There's the fuel tanks for the ascent engine and the oxidizer tanks. There's a place for gaseous oxygen. Where's my light? Gaseous oxygen. I guess here's water and so on. Okay. Again, the descent stage remains on the lunar surface for the entire, it's left on the lunar surface. Okay, next chart. Grumman hired many engineers for the program. One thing that I can tell you about the lunar program was that pretty much the sky was the limit with regard to the funding for the program, which, by the way, is a problem for the next manned space program. Because keeping in mind that when the lunar program was announced, it was announced during a time of the Cold War. It was announced at a time when we really needed, we had some losses in the Bay of Pigs invasion during that time. And so President Kennedy really needed a win. And so he announced that the sky was the limit with regard to funding the program. So Grumman was able to hire many engineers. Among the engineers that were hired were what was called the subsystem engineers. Subsystem engineers were the experts in the various subsystems, and so they were subsystem engineering. My group was reliability engineering, and we were part of systems engineering. And I had people assigned to the various subsystems and working with the subsystem engineers during the design, development, build-up, and test of the program. The electrical power subsystem employed 5 descent stage batteries and 2 ascent stage silver zinc batteries. The environmental control system provided oxygen, the water supply, and equipment and personnel cooling and heating. The navigation and guidance and radar subsystem was